Here we are for the Unit 4 Review Solutions. So hopefully you've already tried these out and you're just coming through to check and make sure you got everything right. That's really going to be the best way for you to prepare. If you're just looking at the solutions, having not tried them already, I can guarantee that you're going to be disappointed. So this is your last warning. Alright, just do a couple examples here. So I'm just going to draw a unit circle for our reference. Let's say that let's find sine of 3 pi, and we'll also find cosecant of 3 pi here. So 3 pi rotated obviously 2 pi, and then another pi radians, which is out here. That'll be 3 pi, and the y-coordinate at that point is going to be 0. Remember, the cosecant is 1 over the sine. So this will be 1 over 0, and that, of course, is undefined. Right, let's do one more here. So let's do the cosine of negative 2 pi over 3. So what you need to realize is that this is moving clockwise. And where's 2 pi over 3? Well, this would be 1 pi over 3, and this would be 2 pi over 3. So I'm going to be down there, and the cosine, of course, is the x-coordinate. So this will be negative 1/2. And then let's find the secant. And the secant of negative 2 pi over 3 is the reciprocal of cosine. So it's going to be negative 2. All right. Radian angle measure. Of course, the way that we define this is using the radius, right? So an angle measure of 1 radian will be an angle whose arc length is the length of 1 radius. So to just sort of be pretty clear here, we define 1 radian to be the angle whose arc length, the arc length that subtends that angle, is equivalent to 1 radius length. So if this is 1, then 1 radian would have an arc length of 1. Okay? So what is the radian measure of the angle shown below? And the way we can figure it out is we can say, okay, how many radiuses are in this arc length? So the angle theta will be 11.5 divided by 5 radians, and that's going to be a little over 2. So it's approximately, let's call it 2.2. Alright, and then given the unit circle below, which quadrant would you be in if you rotate 4 radians? So remember, rotating all the way around the circle takes 2 pi radians. Rotating halfway around the circle takes pi radians. And then this would be 3 pi over 2 radians. And so pi is a little over 3. And so 3 times 3 is 9. 9 divided by 2 is 4.5. So in between here and here would be 4 radians somewhere. So we'd be in the 3rd quadrant. Okay. Alright, so we know sine, and we know that the argument x is somewhere in between 3 pi over 2 and 2 pi. And so if I'm looking at my unit circle here, I know that I'm somewhere in this quadrant here, and I want to find cosine and tangent. So using the Pythagorean identity, I know that cosine squared of x plus negative 8/17 squared will equal 1. And I could take this one step further and start out by saying I know cosine is equivalent to 1 minus sine squared, and that's what I'm going to do in my next step. So I know cosine squared of x is going to be 1 minus, and I'll just go ahead and square this out. So negative 8 squared is 64, and 17 squared is 289. So cosine squared is going to be 289 minus 64, The way I get that is when I'm subtracting, this is going to become 289. And that will give me 225 289ths. And then I need to square root both sides to solve for the cosine. And so cosine of x, and this is going to be plus or minus, right, because I'm taking the square root. Square root of 225 is 15, and square root of 289 is 17. And then I know I'm in the fourth quadrant, and cosine is going to be positive, so this is going to be positive 15/17. And then, of course, you can find the tangent by taking the sine and dividing it by the cosine. So I'd have negative 8/17, and instead of dividing by 15/17, I'll just multiply by the reciprocal, which is 17/15. And 17 over 17 is 1 over 1. So I'm going to end up with negative 8/15 as my tangent. And of course that makes sense because the tangent should be negative, so it has a negative slope. And then I can approximate the value of x by realizing that the cosine here is very close to 1. And cosine is going to be 1 at this point here, at 2 pi. And so I'd say I'm definitely pretty close to 2 pi, but a little below 2 pi. And so I'm somewhere between these two angles here. And so that's how I can narrow down and approximate pi. There's a good video on understanding sinusoidal functions and really going through and understanding what A, B, H, and K represent here. So I would go back and watch that video. Obviously, the absolute value of A is the amplitude, determines how far or below the maximum or minimum are from the midline. K is, of course, the value of the midline, y equals K. B is related to the period, so the greater B is, the more scrunched together the graph is. The period is 2 pi over the absolute value of B. And then H is the phase shift. And last thing I'll say is to make sure you go through and do some problems where you're creating sinusoidal functions. Go back, watch some videos, try out some problems to make sure that you're prepared.